In this question, our goal is to try to rotate this region about y-axis and find the volume. Well, in order to calculate the volume, you can use the washer method or you can use the shell method, but please note that you are rotating about y-axis. If you decide to use the washer method, you have to write everything in terms of y. If you're using shell method, you have to write everything in terms of x. So let's visualize this guy a little bit, see what are we dealing with. So if you plug in 2 here, your y becomes -2. If you plug in 0, you get -8 minus 2, which becomes -10. Okay, this has a very interesting behavior. And when you set y equals to 25, you can find the intersection between them. So when x is equal to 0, my y becomes -2 to power 3 minus 2, or -8 minus 2, or -10. And then if we set y equals to 25 equals to x minus 2 to the third minus 2, maybe we can find the intersection between these as well. So we're basically doing algebra. So bring 2 to the other side, you get 27 equals to x minus 2 to the third. Now take the third root of both sides. 3 and 3, they get canceled out. So on the left-hand side, you have a 3. On the right-hand side, you have x minus 2, so x is 5. So the intersection between these two is at 5. So it gives us a general idea about the behavior of the graph. Perfect. So here we go at 5, and the y equals to 25. Okay, don't have enough space, but we're doing our best to scale this 25, and when x is equal to 5, 5 minus 2, 3, 27 minus 2, 25. Okay, so at 5, we should be just right here. And the behavior of this graph is very similar to, okay, let me move this. I'm using this -10 to x cubed. So this is almost the behavior of this function, almost everybody. And at -10, it hits y-axis. And then we have x equal to 0, which is your y-axis, right? What else do we have? Okay, this is the region that you're having, am I right? And we try to rotate this region with respect to y-axis. Perfect. So this is my region that I try to rotate. It goes a little bit down to the negative side. So here we go. This is my rotation. And let me use some dotted line to show that, hey, this guy is actually rotated about y-axis. So if in order to use the washer method, we need to write everything in terms of y. But pay attention here. This function is not written in terms of y. It's written in terms of x. So since y is equal to x minus 2 to the third minus 2, we're going to isolate x. This is our goal. To isolate x, add 2 to both sides. Y plus 2 becomes x minus 2 to the third. Now take the third root of both sides. So x minus 2 becomes the third root of y plus 2. And in turns, x is 2 plus the third root of y plus 2. Very good. So if we look at the cross section here, the cross section behaves like this. and your radius is located on x equals to 2 plus the third root of y plus 2. There we go. So the volume can be calculated, and it's in terms of y. Y ranges between -10 and 25. That's how your y is changing. -10 to 25 and pi r squared, and this is your r, which is 2 plus the third root of y plus 2 to the second power dy. Very good. Excellent. Okay, now we have a lot to do. You need to go back to algebra, simplify this guy as much as we can, and find the volume. Volume is equal to the pi. I'm going to just take this pi and write it in front. Pi, the definite integral, -10 to 25. I'm going to raise it to the second power. So remember that whenever you had a plus b to the second, it was a squared plus b squared plus 2ab. So we are doing the same thing here. So you have 2 squared plus, we take y plus 2, third root of y plus 2, raise it to the second, plus 2 times the third root of y plus 2, and then dy. This is exponent 3. Or the exponent is a third and the root is 3. You can use u sub for these cases. U can be equal to y plus 2. So du is just dy, and the rest is very simple. So the volume can be written as pi, the integral of 4 plus u to power 2/3 plus 4 u to power 1/3 dy. And dy is now converted into du. Perfect. So the volume is pi times 4u, but u is y plus 2. So you get 4y plus 2 plus. And if you add 1 here, you get 5 divided by 3, or 3/5 y plus 2 to power 5/3 plus 4 times, if you add 1 here, you get 4/3 or 3 divided by 4 of y plus 2 to power 4 divided by 3, and y ranges between -10 to 25. Okay, perfect. We have a lot of algebra to do. So the volume is equal to pi. If I plug in 25 for my y, get 4 times 27 plus 3/5. I have 27 to power 5 divided by 3, which gives me 3 to power 5. Plus, you can cancel 4 and 4. The same here. You have 3 times 3 to power 4 and minus. Now plug in -10. So if you plug in -10 here, you get -8. And here, if you plug in, okay, good, we get -2 then. So you have plus 3/5, -2 to power 5. And here you have plus 3, -10 plus 2 is -8. -8 is -2 to power 3. So 3 and 3, they get canceled out, times -2 to power 4. So the volume can be written as, can we simplify this further and then take the common denominator? Probably, but this is pi times 108 plus, let's see, if I factor out 3 to the power 4 here, I get 9/5 plus 3, or I could factor out 3 to the power 5, it doesn't matter. And here I get -8 plus 3/5 times -2 to the power, so you get -32. And here you have plus 3 times 16. It's pi, and here 108 plus 81 times, if I take common denominator 5, 15, 24. Ooh, we have a lot of algebra here. Minus -8. Okay, so you get +8, and you have plus 96 divided by 5, and minus 48. Very good. Now we need to take common denominator and simplify this guy as much as we can. So basically all we are doing right now is doing algebra, everyone, right? So from this you get a 60 and 68 if you count this as well. And then from these two, if you take common denominator 5, and then you can combine the numerators. Let me use a calculator, much more faster instead of wasting time. So here I have 68 plus the rest of these things. The calculator gives me 500 pi. Okay. This should be the volume using the washer method, everybody. Hope all the algebra are correct, our calculations are correct.